Hello! Today we're going to be talking about graph transformations. It's as cool as it sounds. Let me write it up. Graph transformations. It's whenever we get graphs and we transform them and change them. Alright? For instance, let's do one of the mathematician's favorite graphs, a parabola. F of x is equal to x squared. Now, I can tell you, I'm sure most of you know what the graph looks like. It's a parabola. It opens up like this. However, remember with the f of x table, we are able to determine what are the values of this graph at various points. So we'll pick some symmetrical points about the origin. F of -2 is just -2 quantity squared, which is just a 4. F of -1 is just -1 quantity squared, which is just a 1. F of 0 is a 0. F of 1 is just 1 squared, which is 1. And f of 2 is just 2 squared, which is 4. I come over here, I pick my -2, -1, 1, 2. I go to -2, I find the 4. 1, 2, 3, 4. I put a dot. I go to my -1, I find the +1, I put a dot. I go to 0, I see 0, I put a dot. I go to 1, I find my 1, I put a dot. I go to 2, I find my 4, I put a dot. And at the end, what do? We connect the dots. So here you go. We create our parabola like so. Now, that's the graph. I want to transform this graph. And I will do so in various colors so that you can see it distinctly. Let's consider what would happen if we were to say, well, let f of x not just be x squared, let it be x squared plus a 2. How does that change the graph? Okay? Whenever we add a 2 on the outside of the function like this right here is called a vertical shift. You will see why it is called a vertical shift. Because it causes a vertical change. Our f of x is equal to an x squared plus a 2 now. And our f of x table is like this. So let's pick symmetrical values about the origin again. And let's evaluate this new function. F of x is equal to x squared plus 2. Well, f of -2 is then going to be -2 quantity squared plus a 2. That's 4 plus 2, which is 6. F of -1 is going to be -1 quantity squared plus a 2. That's +1 plus a 2, which is 3. F of 0, that's just 0 squared plus 2, which is just 2. F of 1, that's just 1 squared plus 2, which is 3. F of 2, that's just 2 squared plus 2, which is 4 plus 2, which is 6. So we'll come over here, we'll go to -1, we'll find our 5, 6, we'll go to our -2, we'll find our +6, and we'll put a dot. We'll go to our -1, we'll find our +3, and we'll put a dot. We'll go to our 0, we'll find our 2, I'll put a dot. We'll go to our 1, I'll find my 3, I'll put a dot. And I'll go to my 2, and I'll find my 6 again, and I'll put a dot. Notice when I connect the dots, this is what I get. In the blue, we have f of x is equal to x squared plus a 2. And in the black, we just have our regular old f of x is equal to x squared. Notice now you can see why it's called a vertical shift. Because adding the 2 on the outside raises each of the values by 2. The origin value goes 1, 2. The 1 value goes 1, 2. This value goes 1, 2 from its previous x squared value in its f of x is equal to x squared plus 2 value. All the values go up. And I know what you're thinking. What if I were to have subtracted a 2? Well, if you were to have subtracted a 2, all the values would have gone down by 1. We just elected to add because mathematicians are positive folks. Okay? Now, we've discussed the vertical shift. That's not the only kind of shift we can have. If we can shift vertically, then we must also mathematically should be able to shift horizontally. How do we invoke a horizontal shift, you ask? Well, let me show you. And this one is going to be in green. So I'm going to clear up some real estate. Let's have our f of x now be quantity x minus a 2 squared. All right? Now, we're going to pick symmetrical values about the origin again. Let's get a better marker here. This one is kind of faded. Let's get -2, -1, 0, 1, and 2, symmetrical values about the origin. And so f of -2 is the same thing as -2 minus the 2 quantity squared. That's -4 squared, which is 16. F of -1, that's a -1 minus the 2 quantity squared. That's -3 squared. Square that, we get a 9. Here's 0, f of 0. That's 0 minus 2 quantity squared. So that's just -2 quantity squared, which is just a 4. Then f of 1, that's just 1 minus 2 quantity squared. That's -1 squared, which is just a 1. Then we get f of 2. That's just 2 minus the 2 quantity squared, which is just 0 squared, which is just a 0. Okay, let's go over here and plot this. At -2, I have a positive 16, which is way up here. So maybe this is 10. Maybe this is 20. Here's 15, and so at -2, I'm at positive 16. It's a little bit above that 15. All right, and at -1, I'm at 9, so I'm just a little bit below this 10. Then at 0, I'm at 4. Put a dot here at 4. At 1, I'm at 1. That's interesting. And at 2, I'm at 0. Okay. Now, for the sake of seeing what this function is doing, because it seems to finally hit the arc and keep moving on, let's just do it at 3 as well. What is this function at f of 3? F of 3 is really just a 3 minus a 2 quantity squared. That's just 1 squared, which is 1. So at 3, it's at the value 1. So that's when we connect the dots, that's where it's deciding to go. Notice that the green forms a parabola that looks just like f of x is equal to x squared. However, it's shifted to the right by 2 places in each spot. This is my f of x is equal to quantity x minus 2 squared. As you can see, whenever this occurs, this f of x is equal to the quantity x minus 2 squared. This is called a horizontal shift. If this were to be a plus 2, it would be shifted here to the left. If it's a minus 2, it gets shifted to the right. Why is it so counterintuitive? Well, one way to think about it is, it just is. Whenever you tabulate the results, that minus sign ends up creating a horizontal shift to the right, and a plus sign would have caused a horizontal shift to the left. Another way to think about it is, well, if it's a squared result, then the minuses will get squared anyway, so that means a negative times a negative is a positive, and that's why it involves a positive shift instead of a negative shift. But either way, these are some examples of a quadratic function and 2 different ways in which it can be transformed, either a vertical shift or a horizontal shift.